This first question requires us to give two more details to this method that will give an even more accurate result. So if we look to the method, we've got a concentration of dilute sulfuric acid can be determined by titration. 25 centimeters cubed of dilute sulfuric acid was measured out using pipette and transferred to a conical flask. That's fine. A few drops of methyl orange indicator was added to the acid in the conical flask. Sodium hydroxide solution was added to the acid from burette until the indicator changed colour. The titration was repeated until two concordant results were obtained. The average of those two concordant results were taken. So the first thing that they haven't done whilst they're adding the two things together is they haven't swirled. So our first point needs to be about swirling the mixture as you're adding the sodium hydroxide. The reason for that is that if you don't swirl, then you get a concentrated pool of sodium hydroxide in the middle of the solution, and if that's not mixing with the rest of the solution, then it won't react evenly. Second thing you could say is that when you add near the end point, so you do a rough titration first, you would add drop-wise near the end point. So what I mean by that is they would add the sodium hydroxide drop by drop when you're near to where it might change colour, so that you can stop the adding immediately when one drop changes the colour, that's when you stop. If you don't do that, then it's going to be very difficult for you to stop right on the point of neutralising. The final thing I suppose you could write about it is the use of a white tile. So you put a white tile underneath the conical flask so that you can see this colour change really clearly. If you use a coloured work surface or worktop, then maybe that colour change would be obscured. So those are the three things that I would choose from, and those two probably the best two to use. So here we've got a calculation question for titration. So again, like the moles questions or the mass calculation questions, we're going to use Mr. T as our guidance. So the first step is, well, let's first read through the question. So it says, the student was asked to plan a titration experiment to find the exact volume of hydrochloric acid that would neutralise 25 centimeters cubed of sodium hydroxide. The student used 25 centimeters cubed of a 0.5 mol per dm cubed sodium hydroxide solution in the titration, and 22.85 centimeters cubed of hydrochloric acid was required to neutralise sodium hydroxide. So our first step is M, which stands for moles. Now we can work out the moles of the NaOH in this titration because we've got a concentration and a volume there. So the triangle that we need to be using for titration calculations is that moles equals concentration times by volume. So the first step is to work out the number of moles of NaOH, and that equals 25 times by 0.50, and then we've got to divide the whole thing by 1,000. The reason we've got to do that is we've got centimetres cubed here for our volume, and we've got moles per dm cubed here for our concentration. So decimeters cubed here is not compatible with the centimetres cubed. We've got to make them both the same thing. So to convert these centimetres cubed into decimeters cubed, we divide by 1,000. So that will give us 0.0125. Then our next step is R in this process, and that is to work out the ratio, or use the ratio from this equation here. And what we're trying to work out here is the concentration of the hydrochloric acid. So what we've got to look at is what is the ratio between the sodium hydroxide and the hydrochloric acid. Well, it's 1 to 1. So the moles of the hydrochloric acid is going to equal the same as the moles of the NaOH we've just worked out, which is 0.0125. Then finally we're going to use the appropriate triangle to work out what we've got to work out, and it's asked us to work out the concentration of the hydrochloric acid. So this triangle here is the appropriate one, and we're trying to work out concentration, which means we're going to do moles divided by volume. So the concentration of the HCl is going to equal moles divided by volume, which equals so moles was 0.0125, and we've got to divide by the volume in decimeters cubed. So here is the volume in centimeters cubed, so we to divide by 1,000 to give it in decimeters cubed, and that gives me the answer, which is 0.54704595. And then with any question that's worth more than 3 marks, I recommend that you read the answer and then check the question. And you'll see that the question asks you to give your answer in 3 significant figures. So our final answer will be 0.547. So here's our final titration question. So we've got the concentration of dilute sulfuric acid can be determined by titration with sodium hydroxide. So we've got a certain amount of sulfuric acid, it's pipetted out, we add some methyl orange, and then sodium hydroxide was added to the acid from a burette. And then we've got a concentration and a volume of the sodium hydroxide used, and the volume of the dilute sulfuric acid. So we're going to use, again, Mr. T to give us guidance. Our first step is to work out moles. We've got the concentration and we've got the volume of the sodium hydroxide solution used. So I can work out the moles of the sodium hydroxide, which equals, and remember we need to use this triangle here, so it equals concentration times volume, so that equals 0.200 multiplied by 24.25, but remember we've got to divide that by 1,000 because the 24.25 is in centimetres cubed and the concentration is worked out per decimetre cubed, and that gives us 0.00485. So the next step is now to use the ratio, so R. So there we're using this equation here, and we're trying to work out the moles of sulfuric acid because that is what we're trying to work out in the end. And you'll notice that the ratio of sulfuric acid to sodium hydroxide is 1 to 2. So for every 2 moles of sodium hydroxide, we use 1 mole of sulfuric acid. So to work out the moles of the sulfuric acid, we've got to do the moles of the NaOH divided by 2, which equals 0.00485 divided by 2, which gives us 0.002425. And then finally, use the appropriate triangle where we're working out concentration, so therefore this is our appropriate triangle. So the concentration of the sulfuric acid is going to equal moles divided by volume, which equals 0.002425, which is worked out here, divide by the volume. Now the volume is 25 centimetres cubed, but we've got to convert that into decimetres cubed by dividing by 1,000. So that's 0.025, and that gives me 0.097. And what I do is just look back at the question, read your answer, check the question. Does it ask us to do certain significant figures or decimal places? No, it doesn't. So that is your final answer.